Want to predict customer churn with confidence? In this video, we will guide you through building, training and deploying a high-performing churn prediction model using TensorFlow step by step. So let's turn data into actionable insights. Hello everyone, welcome back to another interesting video by Edureka on Introduction to TensorFlow. Before we begin, please like, share and subscribe. Remember to hit the bell icon to stay updated on the latest content on the Edureka's YouTube channel. Also, check out the Edureka's Generative AI certification courses. The course link is in the description box below. Well, this video is going to be very interesting, so let's break it down through our agenda. First, we will introduce TensorFlow, a powerful open source machine learning library. Next, we will explore real-world applications of TensorFlow and then guide you through the installation process. Next, we will dive into the TensorFlow ecosystem and discuss its key features. Finally, we will conclude by building a churn model using TensorFlow, providing a practical demonstration of its capabilities. So, let's begin with the question, what is TensorFlow? TensorFlow is a popular open source framework developed by Google for building and training machine learning models. It's like a toolkit for creating artificial intelligence systems. TensorFlow can be used for various tasks, including neural networks, computer vision, where computers learn to see and understand images, and natural language processing, where computers can understand and use human language. So now we got an understanding of TensorFlow, so let's get deeper into it. TensorFlow is a versatile machine learning framework that utilizes tensors, multi-dimensional arrays, and computational graphs to perform operations. This architecture makes it adaptable and scalable for various machine learning tasks. TensorFlow caters to users with different levels of expertise by offering both high-level APIs like Keras for simplified model building and low-level APIs for greater customization. Furthermore, its capabilities with CPUs, GPUs and TPUs ensures its suitability for both small-scale research and large-scale production environments. Now that you are familiar with TensorFlow, so let us see its significance in AI and machine learning. TensorFlow is a powerful platform that empowers developers to transform AI and ML ideas into scalable solutions, seamlessly transitioning from research prototypes to real-world applications. It is adaptable to diverse needs with features like visualizations and debugging tools that enhance model understanding and troubleshooting. TensorFlow streamlines the entire machine learning pipelines, enabling efficient handling of large datasets and complex tasks while ensuring scalability and performance. Its versatility allows it to be customized for various applications, from simple experiments to advanced AI systems. Ultimately, TensorFlow has a real-world impact by enabling developers to create innovative solutions that address global challenges and drive technological progress. Now that you know the significance of TensorFlow, so let's discover why to use TensorFlow. TensorFlow is one of the leading deep learning frameworks widely used for machine learning and AI research and production. Its scalability allows TensorFlow to handle massive datasets and complex models efficiently, making it ideal for large-scale AI systems in applications like image recognition and natural language processing. Next, flexibility. Flexibility is another key strength, as TensorFlow offers APIs ranging from high-level Keras for simplicity to low-level APIs for advanced customization, catering to diverse developers' needs. Next, its rich ecosystem includes an active community, extensive documentation, pre-trained models, and numerous resources that simplify its adoption and usage. TensorFlow's cross-platform support enables seamless deployment across different operating systems and hardware platforms. Finally, its optimized performance, as TensorFlow runs efficiently on CPUs, GPUs, and TPUs, ensuring faster training and inferences times. These strengths such as scalability, flexibility, ecosystem, cross-platform compatibility, and optimized performance make TensorFlow a preferred choice for AI and ML projects. Now that we know what is TensorFlow, so let's compare TensorFlow with other frameworks. So here is the comparison between TensorFlow and another deep learning framework, likely PyTorch, highlighting their respective strengths. TensorFlow is known for its flexibility and versatility, enabling developers to build a wide range of models with customizable implementations, while PyTorch is recognized as initiative and Pythonic, offering a user-friendly approach that appeals to many developers. Next, when it comes to production readiness, TensorFlow excels with robust tools for deploying models in real-world environments. Whereas PyTorch is more research-focused, favored for its dynamic computational graphs and ease of experimentations. Next, TensorFlow boasts a large and established ecosystems with an active community, extensive documentation, and a proven track record, while PyTorch is growing rapidly in academic circles, gaining traction as a popular choice for research projects. In terms of performance, TensorFlow is optimized and scalable, capable of handling large-scale models and datasets efficiently, while PyTorch is seen as a competitive alternative, offering its own strengths and appealing to a different subset of developers. Ultimately, the choice between TensorFlow and PyTorch depends on the specific use case and developer preferences, as both frameworks offer compelling features suited to different needs. Next, let's explore the real-world applications of TensorFlow. Real-world applications of TensorFlow in computer vision, showcasing its versatility and impact across various fields. TensorFlow is widely used for identifying objects in images, with algorithms like YOLO, You Only Look Once, and SSD, Single Shot Detector, enabling tasks such as detecting pedestrians and obstacles in self-driving cars or identifying suspicious objects in security systems. It plays a crucial role in medical imaging and satellite imagery, where it aids in analyzing X-rays or MRIs to detect anomalies and assist in monitoring deforestation, identifying land use patterns, and predicting natural disasters. Additionally, TensorFlow powers security systems and user authentications, enabling facial recognitions for tasks like facial detection and identifications. This application highlights TensorFlow's ability to transform industries like healthcare and security, making it an indispensable tool in computer vision. Next, TensorFlow in natural language processing. TensorFlow is instrumental in tasks like spam detections and sentiment analysis, where it helps identify spam emails and determine the emotional tone or polarity, which is positive, negative, or neutral of text, such as customer reviews or social media posts. It provides services like Google Translate, enabling accurate translations between numerous languages and facilitating global communications. TensorFlow also enhances security systems and user authentication by analyzing text data to detect suspicious patterns, fraudulent activities, or by improving authentication process through text-based inputs like passwords and security questions. These applications demonstrate TensorFlow's versatility in advancing communication, enhancing security, and driving innovations in NLP. TensorFlow in the field of generative AI, showcasing its role in driving innovation. TensorFlow powers GANs as similar models, enabling the creation of realistic images, art, and even the manipulation of existing visuals. It is instrumental in training large language models like GPT, which stands for Generative Pre-trained Transformers, translate languages, write creative content, and perform summarization tasks. Additionally, TensorFlow facilitates the creation of deep-fake audio and speech generation, producing synthetic media where a person's likeness or voice can be convincingly replicated. These applications demonstrate TensorFlow's pivotal role in advancing image creation, text generation, and audio synthesis within the field of generative AI. Now, let us explore the industrial use of TensorFlow. There are diverse applications of TensorFlow across various industries, showcasing its transformative impact. In healthcare, TensorFlow is used for predicting analytics to forecast disease outbreaks, identify high-risk patients, and optimize treatment plans, as well as for medical image analysis to detect anomalies in X-rays, MRIs, and CT scans. In autonomous vehicles, TensorFlow powers object detection systems, enabling safe navigation and supports decision-making models in industries like supply chain management and risk assessment. In finance, TensorFlow is utilized for algorithmic trading, analyzing market trends, and detecting fraudulent transactions. Retail applications include inventory management to predict demand and reduce stock outs, along with personalized recommendations to enhance customer experience and boost sales. In entertainment, TensorFlow facilitates content creation, such as generating music or art, and it is used in video and audio processing tasks like noise reduction and voice stabilization. Overall, TensorFlow's versatility and advanced capabilities are driving innovation across these industries. Now, let us move ahead and install TensorFlow. To get started with TensorFlow, you first need to install the necessary prerequisites including Python 3.5 or a higher version. You can use a package manager like pip or conda for installation. Here's how you can proceed based on your operating system. First, open your terminal or command prompt and run the following command to create a virtual environment. And the command is python-m virtual environment my environment. Next, activate the environment. For Linux or Mac OS, activate the environment with the following command. And the command is source my environment/bin/activate. For Windows, activate the environment by running my environment /scripts/activate. Once the environment is activated, you can install TensorFlow by running pip install TensorFlow. Now, to ensure that TensorFlow has been installed successfully, you can verify the installation by running the following command, and that is python-c. Inside the double quotes, type import TensorFlow as tf print. Inside the bracket, type tf dot _version . And this will display the installed version of TensorFlow, confirming that the installation was successful. Once the environment is activated, you can install TensorFlow by running this command, pip install TensorFlow. Now, let us open our VS Code terminal and install the TensorFlow. So let us type the command pip install TensorFlow. As you can see, TensorFlow is installed. Now, to ensure that TensorFlow has been installed successfully, you can verify the installation by running the following command. So now, let us run this command in our terminal. Now, as you can see on the screen, the version is displayed. So, this will display the installed version of TensorFlow, confirming that the installation was successful. Now, let us discuss TensorFlow ecosystem. The TensorFlow ecosystem provides a comprehensive set of tools for building, training, and deploying machine learning models. At its core is TensorFlow, the foundation of the ecosystem. TensorFlow Lite enables running models on mobile and embedded devices, while TensorFlow Extended supports building production-grade ML pipelines, including data validation and model serving. Next, the TensorFlow Model Garden offers pre-trained models and examples for tasks like image classification and NLP. TensorFlow.js allows running ML models in web browsers, and TensorFlow Hub provides a library of pre-trained models for easy integration into projects. Now, let us take a look at the key capabilities of TensorFlow, where we will be showcasing its strengths as an open-source, community-driven framework that evolves through contributions. At its core, TensorFlow utilizes tensors, multi-dimensional arrays for efficient data representation and manipulations. Its flexible architecture allows developers to choose between static graphs for optimized performance and eager execution for an interactive development experience. TensorFlow supports a wide range of applications, including natural language processing, generative AI, computer vision, and more, making it highly versatile for various machine learning tasks. Furthermore, it offers cross-platform compatibility, running efficiently on CPUs, GPUs, and TPUs, enabling developers to leverage the best hardware for their needs. So overall, TensorFlow stands out as a robust, adaptable, and versatile framework for machine learning. Now, let us head towards hands-on. There are three main steps in building a churn prediction model using TensorFlow. In step 1, a model is created by defining its architecture, including layers and parameters tailored to the specific problem of prediction customer churn. In step 2, the model is trained using historical data, where it learns patterns and relationships that help predict customer behavior. Finally, in step 3, the trained model is used to make predictions identifying customers likely to churn based on input data. This process demonstrates how TensorFlow can be effectively utilized for churn prediction in machine learning projects. Now, without any further delay, let's code it. So first, let us import the libraries. So let us import TensorFlow as tf. Next, import matplotlib.pyplot as plt. Next, from TensorFlow.keras, import sequential. Next, from TensorFlow.keras.layers, import flatten, dense. So over here, we are importing the TensorFlow library a popular framework for machine learning and deep learning. Next, import matplot's plotting model for data visualization. Then we are importing the sequential class from TensorFlow's Keras API, which is used to build models layer by layer. Next, we are importing the following Keras layers, which is flatten and dense. Flattens multi-dimensional data into a 1D array for input into dense layers, and then dense creates fully connected dense layers for the neural network. And this imports set up the tools needed to build and train a neural network, and then visualize data and results. Now, to get the data and split it for training and testing, let us write the command. So inside the bracket, let us type train underscore images, comma, train underscore labels, and give comma, and again inside the bracket, let us type test underscore images, comma, test underscore labels, and equal to tf dot keras dot datasets dot mnist dot load underscore data. So this code loads the mnist dataset of handwriting digits using TensorFlow. Here, the train images and train labels were images and labels for training 60,000 samples. And the test images and test labels are where the images and labels for testing 10,000 samples. Here, each image is a 28 by 28 grayscale image, and the labels represent the digits 0 to 9. Now, let us scale down the values of the pixels from 0 to 255 to 0 to 1. So, for that, let us type train underscore images equal to train underscore images by 255.0. Next, test images equal to test images by 255.0. Now next, let us visualize the data. For that, print, and inside the bracket, let us type train underscore images dot shape. Next, print test images dot shape. And finally, print train underscore labels. So in this code, the print train images dot shape displays the shape of the training images dataset. So let us run the code to check the output. So as you can see the output, here it says 60,000, 28, 28. This means there are 60,000 images, each of size 28 by 28 pixels. Next, we have the code print test images dot shape, which displays the shape of the testing images dataset. So the output here is 10,000, 28, 28, which means there are 10,000 images, each of size 28 by 28 pixels. The next piece of code is train labels, which prints the labels digits 0 to 9 for the training set. Now, let us display the first image. So for that, let us type plt.imageShow, and inside the bracket, let us type train underscore images at index 0, comma, CMAP equal to gray inside the single quote. To see the graph, let us type plt.show. So over here, the plt.mshow train images, this displays the first image in the data set, which says train images of index 0. Then CMAP equal to gray ensures that the image is shown in grayscale. So let us run this code. So as you can see the screen, here is the output. Now let us move ahead. The next step is to define the neural network model. So let us type my model equal to tf.keras.models.sequential function. Next, type my model. Okay, next is my model.add flatten, and inside the bracket, let us keep input underscore shape equal to 28, 28. Okay, next let us type my model.add, and inside the bracket let us type dense and open bracket and write 128, activation equal to, inside the single quote let us type ReLU. Next type my model.add, and inside the bracket let us type dense. Again open the bracket and let us give 10 comma activation equal to softmax. So over here the tf.keras.model sequential, which creates a sequential model where layers are added one after another. And next we have this code myModel.add flatten input shape equal to 28, 28, which flattens the 28 by 28 input images into 1D array of 784 values and making them suitable for the dense layers. And the next code myModel.add dense 128 comma activation equal to ReLU, which adds a dense fully connected layers with 128 neurons, and then the activation equal to ReLU, which applies the ReLU activation function to introduce non-linearity. And the next code, which is myModel.add dense 10 comma activation equal to softmax, which adds the output layer with 10 neurons corresponding to the 10-digit classes, which is 0 to 9. And activation equal to softmax outputs probabilities for each class. Now let us compile the model. The network will be actually created. So let us type myModel.compile, and inside the bracket let us give optimizer equal to, inside the single quotes let us give Adam, comma, loss equal to, inside the single quote let us keep it as sparse underscore categorical underscore cross entropy, comma, metrics equal to accuracy. Over here the optimizer equal to Adam uses the Adam optimizer, an efficient and widely used algorithm for optimizing neural networks. This specifies the loss function for multi-class classification where labels are integers. Next, the matrix equal to accuracy tracks the model's accuracy during training and evaluation. Next, let us train the model. So for that, let us type myModel.fit, inside the bracket type train underscore images, comma, train underscore labels, comma, epochs equal to 3. So here the myModel.fit, this is a function where it trains the model with the provided data. And then we have the train images comma train labels, where the input data train images and corresponding labels, which is train underscore labels for training. Next is the epochs equal to 3. The model will go through the entire training dataset 3 times to learn patterns. Next, let us check the model accuracy on the test data. For that, let us type value underscore loss, comma, value underscore ACC equal to myModel.evaluate, and inside the bracket let us type test underscore images comma test underscore labels. Next, let us give a print statement. So type print test accuracy of my model, comma value underscore ACC. So here in this code, myModel.evaluate evaluates the model using the test images and their corresponding labels, which returns two values, which is value loss, the loss on the test set, and the value ACC, the accuracy on the test set. And next statement we have print. So this will display the test accuracy, showing how well the model performs on unseen data. Now let us check the output. So let's run the code. So as you can see the screen, the model is finding patterns in 3 iterations because we had set the epochs to be 3. And here you can see the accuracy is 0.97%. So let us change the epochs value to be 50. So initially we had set 3, so now let us give 50 and run the code. Now as you can see, it's making 50 iterations. However, achieving perfect accuracy on the training set could also indicate potential overfitting, where the model might not generalize well to new unseen data. So to confirm the model's effectiveness, it is essential to evaluate its performance on a separate validation or test dataset. And if the accuracy remains high and the loss is minimal on the test set, the model can be considered robust and effective. And with this, we have come to an end to this video on Introduction to TensorFlow. If you enjoyed listening to this video, Please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. Also, do look up for more videos and playlists and subscribe to the Edureka YouTube channel to learn more. Happy learning!